Alright guys, welcome to lesson 6.2. Today we're focused on two things. Number one, being able to explain what the Pythagorean Theorem is by explaining patterns that we see. And then number two, we're going to be able to hopefully find the missing side lengths of right triangles, triangles with a right angle. This is a right angle, 90 degrees, in both radical and decimal form. Those are our two learning targets today. So if you see this image here, it's the image that we use to help explain the Pythagorean theorem. We have three triangles, the red one, the green one, and the blue one. And they're all drawn on the sides of the right triangle. So we have the little blue square, the larger green square, and then the largest red square. And the whole purpose of this is hopefully that you can start to see, well, what happens? This is our Pythagorean theorem. We have that a squared plus b squared equals c squared. What does that mean? A squared plus b squared equals c squared. What does that mean? We're trying to figure that out. What is the significance of that? How does that work? So, a squared, a times a times a, which is a squared, which is the area of this square, which is 9, right? 3 times 3, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 square units. Plus b squared, the other side length, the two sides that are attached to the right angle. So b squared, b times b, b squared, b times b is b squared. So b times b, 4 times 4 is 16, equals c squared, equals c times c, which is 1, 2, 3, 4, 5 times 5. 5 times 5 is 25. So we have a, which is 9, because a squared is 9. A times a is 9, plus b, which is 16. Does that equal 5 times 5? 25. And it does. 9 plus 16 equals 25. And that is the Pythagorean theorem in a nutshell. If we draw triangles off of the sides, right, or squares off to the sides of the triangle, the area of the square from this side and this side, the two legs we call them, that attach to the right angle, their areas of the squares will equal the area of the square formed off of what we call the hypotenuse, the longest side, this side across from the right angle. Alright, so let's look at this. Let's see if we can kind of create a chart here. So, if we have, this is the first one that's up there, AC is 3, BC is 4, that's the length of AC is 3, and BC is 4, and AB is 5. Area of A was 9, area of B was C, and the area of C was 25. This chart's going to be on our quizzes and tests this unit, so it's something you want to pay attention to. If the area of A was 25, what would the side lengths be? Remember, area of a square, we have to do the square root of that. So what's the square root of 25? That's 5. Okay, so if BC is 12, that's the length of BC. What's the area then? 12 squared is 144. 25 plus 144 is 169. The square root of 169 is 13. 7, so 7 is the side length. AC is 7. So 49 would be the area of A. If BC has a set 576 area, unit squared area, then we have to square root that. We have to square root that, 576, square root that, find the square root, to find out the side length, which is 24. And this one's 25, and we know that 25 times 25 is 625. So this one's 625. And hopefully we can identify that 49 plus 576 equals the area of C, 625. This plus this should equal that. This plus this should equal that. This plus this should equal that. The area of A plus the area of B should equal the area of C. So if this area is 64, that means the side length is the square root of that is 8. If this is 15, then the area of that is 15 times 15. 15 times 15 gives us an area of 225. You add them together and we get 289. The square root of 289 is, oops, I typed something wrong. Square root of 289 is 17. Hopefully you're starting to see how the Pythagorean theorem works. Area of the square off one leg plus the area of the square off another leg equals the area of the hypotenuse, the longest leg across from the right angle. So how is the area of squares A and B related to area C? I kind of gave it away. I did give it away already. Area of A plus the area of B equals the area of C. So what is the Pythagorean theorem? Pythagorean theorem states that a squared, the area of side A, one of the legs, plus the side another leg, B squared, equals C squared. Let's look at an example. So we have one given side here, we have a side here, and we're missing this side here. So if we look at the Pythagorean theorem, a squared plus b squared equals c squared. Which of these are we given? These two are kind of interchangeable. These are what we call the legs. This is a leg, and this is a leg. This long side, this is always has to be the longest side, the one across from the right angle. Across from the right angle is always the longest side, and this is what we call the hypotenuse. This is what we call the hypotenuse, this one across from the right angle. And the hypotenuse is always the longest side. So we know that the legs, when we square this leg plus the square of this leg, has to equal the square of this. So we know that 8 squared plus x squared has to equal 10 squared. So we know that this squared, let's say that this is 8, 1, 2, 3, 4, 5, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 8, let's say this is 8 by 8, so it has an area of 64. And this, we don't know what this is, but this we know, if I could draw better, this we know is 10 by 10. So this one has an area of 100. What's this one going to be? What's this area going to be? Anybody know? It's going to be 36, because 36 plus 64 equals 100. So what we're going to do here to solve this, we're going to do 64 plus x squared equals 100. We're going to subtract 64. We're going to go x squared equals 36, and then we do square root, which gives us x equals 6. And it couldn't be negative 6 because there's no, you can't have a negative side length. You can't have a side length that's less than 0. Let's look at another example. So a very similar example. We're missing a leg. We're given one leg. We're given the hypotenuse. So here we have a squared plus b squared equals c squared. A, we'll call that x squared. B, we'll call that 3 squared. Remember, a and b it doesn't matter which is which. They're just these two legs, okay? The leg and the leg, because this is our right angle. this is the hypotenuse. It's just always the c. This is always the c, the one across from the hypotenuse. So that's 8 squared. So we know that x squared plus 9, because 3 times 3 is 9, equals 64. We subtract 9, we subtract 9. So x squared equals 64 minus 9 is 55. So we did 64 minus 9, and we get 55. But I don't know what the square root of 55 is. So this is what we call radical form. We know that the side length that we are missing is 55, the square root of 55. This is called radical form, and that's one of our learning targets, radical form. So this is in radical form. And then we could estimate this. We know it's more than 7, less than 8. We could estimate it with a calculator and get about 7.4 as a decimal. So 7.4, about 7.4. The next example, example 4, we're looking at this one. We're missing the hypotenuse. Okay, we're given each leg. We're given leg. Oh man, I don't think it'll let me go down that far. So we're given this leg and this leg. But we're missing the hypotenuse. So we're going to do 4 squared plus 3 squared equals x squared. Because we have A, we have B, we have the 2 legs. What we're missing is our C, our hypotenuse, our C. So we're going to do 16 plus 9 equals x squared. 16 plus 9 is 25 equals x squared. Square root those. So this is in radical form. But this one we can solve right down. It's a perfect square. So our missing side length is 5. X equals 5. Okay, so today, what have we learned today? Lesson 6, Unit 6, Lesson 2. We've learned how to explain the Pythagorean theorem by observing patterns. How the area that's formed from one leg of a right triangle plus the area formed from another leg of a right triangle is always going to equal the area formed from the hypotenuse, the longest side of a right triangle. We've also learned how to find the missing side length, any missing side length, if we're given the other 2 side lengths of a right triangle in both radical and decimal form. Next time, guys, we're going to keep working more on this Pythagorean theorem concepts and practice it. Make sure you get this done, have it ready for me by next class. See you then. Signing off, this is Mr. Herschel.